Good evening, ladies and gentlemen, and welcome to another video of where we're going to take a look at how we can make a parametric umbrella like this one here. It is a rather complicated thing to do, and this script is a little bit more advanced than we want to go into here. But what is still interesting, you basically have this basic form like this, and then it goes out and it creates and unfolds itself, and then a certain mesh goes over it, and then you have basically a finished structure that you can live or be under. So if you want to go with me and go through the tutorial and how I got my thought process into that, then let's stick around and learn about this together. So let's just start with a new file in Grasshopper. So I'm just gonna sketch this out really quickly inside our canvas here. So if we have an umbrella, one like those, you see, you have basically those little kind of things here. You have the basic shaft that moves upwards, and then you have those strings that basically push it outwards, so it has this shape to it that it stays up front. And then when you push this one back in, this retracts again and you have your umbrella in the basic shape. So you basically, if we draw it now in the section, it would be kind of this shaft here, then you have this thing going out, and then you have those little pieces coming out from those places here, and then you have the main thing that is connected to those points here. And when this, actually this should be here more, and when this moves up, it wants to go up as well, or like down. So we kind of get through this in a matter of time. So anyway, first of all, we're going to start with the main structure from above. So you have the umbrella, right? And normally you have all those different like lines like those, right? And we want to construct those lines first, or basically the plane for that at the beginning. So we're going to simply create a point, or a construct point, and then this point will be moved upwards at a certain dimension. We're just gonna use 1000 for now, 100, and so this would be like our base position. Actually, do it, I think 100 is fine. And we want to now create as well a plane in this, at this point, like this. And we basically want to create this plane so it will create all those different pieces here. And we're going to do this by just simply doing a under vector grid, and then we go to radial. No, I'm sorry. We go under, I think it's yeah, polar array. It is under transform array polar array, and from there we basically will take the geometry that we have here. The plane doesn't matter in this case, and then we also take the count, so like how many of those branches you want to have. And you see it creates basically this those planes in that same space. So now we want to create a line that also connects those points to the points here at the bottom, and we're just gonna use just point like this. So starting point, we use the plane here, or the point, doesn't really matter, and the other one would be just a 0, 0, 0 point for now, like this. So just be our basic shaft. And now that we created that, I want to create the lines that go into those directions. So I'm going to do this by doing a construct like line SDL, I think, yeah. And the start point would be that. And then we also want to have the direction, and the direction will be dependent on the plane that we defined here. So we're just going to type in deconstruct plane, and this plane will give the x, y, and z axis, and we want to have the x-axis for the direction, and the length would be the umbrella length that we want to have, like here. So we're just gonna type 100 again, I guess, and put this in here. So now we already have our basic umbrella shape like that. Okay, just rename this amount of wires. That's kind of a weird way of saying it, but okay. Okay. Now that we have defined our basic shape, we want to, in the umbrella, you have also this point where it kind of curves here in this case as well. So what I want to do is just simply creating a more like a middle point, or a point on this curve that will connect to this middle point here, like to the shaft here in the middle. So I'm going to do this by evaluating the curve, and we're going to evaluate the curve in the parameter, and it goes from 0 to 1, and this will then create the point that we want to connect it to. And we also might need to advance this further there as well. We do the same thing with the other parameter here, and we're gonna give it a separate place like that. Okay, and if we now put a line through here, it needs to connect to this point. So now we have that point defined as well. This will be a placeholder for now. We might want to change this later as well. Okay, now that we have that, we want to modify the curve that we defined here, because it still goes straight, but we want it to be angled. So we're going to use the shatter command, and it takes the parameters of the curve where we want to basically break it up. So we're going to use the input curve that we had here, and then the parameter of the point that we defined before, and this gives us 2 points in the shattered of those shattered curves. Actually, let me, so you can see the commands better, use this command. You can ignore that. So then now you have the shattered curve like this. We also want to change the curvature here, or change the direction basically. And we're going to do this by using the rotate commands. And the geometry that we want to rotate is one of those two things. So we're going to do list item, and we're going to choose between the number between the right one. So we want to move this one. So this will be geometry that we want to rotate. The angle will be some angle that we define, or in radians. We can also do it in degrees, but for now we do it in radians. And then the plane needs to be adjusted, because as you see right now it's just doing it like this, and this doesn't really work. But we want to create it from those base planes here. So now if we would put those in, it creates some kind of mess. That's because we also need to graft it as well. But it also doesn't really work as intended, because you want to move it around this point. So what we need to do, we actually need to move the those planes that we had here and move them to the point there. So we're just gonna use the move commands, and then we're gonna use a vector between this point here and the point that we defined here, and connect those two together. And now we're gonna move the plane that we had here in the beginning and move that plane to this point. And now you see that's why we want to have the planes at the beginning. We moved the plane right over there. Great. So now we have the plane defined, and we want to rotate it around, and we already had it here, so we're just gonna plug this one in here, and you see it rotates at the correct size. And we just want to do it negative as well, so we have some leeway into the other direction as well. So like this. Okay, let's just hide some of the things that we made for now, so we can have a better understanding of that. Actually, let me there's a command of how you can oh no, this is deactivate. I don't want deactivated. Control E, Control F, Control. No, there's a, you can also do it with Control, but for now we just do it like this. Anyway, now we have our those things defined, and we also want to have the other one as well in this case. So like that. Now we have our two little things set up. Furthermore, they can also be connected together if we're just using arc. So we can use the endpoints, for example, from this one, or like from the rotated one like that. Or we can also just, maybe that's actually a better way to do it. We will join those two curves together for now, like that, with shift click, and it connects those two together, and it will create a curve. And we want to now explode them like that. And now we have the segments, or the vertices, I mean, and we can just separate them with like list item. And we will just copy this 2 times, and this one will be like set integer 0, set integer 1, and set integer 2. Like this, 1, 2, 3. This doesn't work because it needs to be at the vertices like this. Great, now we can decide that, and we have our very nice curve that we want to have here in the beginning, like that. Very good. Now that we have that, when we, for example, we might also want to make this like smaller, right? So wait, let me just see. Because now we want to move those things as well downwards. So the more we move it downwards, we will actually want them to be more straight as well. So like more like this, if it's like moved like that. So we're going to rotate the geometry that we have here, and we use the angles as we just can use degrees in this one, because I'm not that good with radians yet. So yeah, I guess I need to do it quickly like that. And the planes will be the planes that we defined in the beginning here, and we need to graph them as well. And we want to, because this one will be like starting like there, we want to basically be like this, right? However, we want them to be straight as well. So that can be done with doing it so if this number here is closer to 90, that this will be closer to 0. So we're going to use a multiplication like this, and the multiplication will be 1 here, and when we define it, or no, it will not be, I think it will be division, right? So we divide this one here by the max amount of like minusness of how we define the plane, or the starting point here, and this will be then a result of that. Right, let me actually take a look. This should be then closer to 1. What should be the other way? We can just have 1 over x, I guess, and that would then result in something completely different. That shouldn't be the case. Wait. Okay. So let me actually think for a second here, because we have our basic angle here, and the closer this is to 1, the better it is. Or we can also make it so we just have the, that might be better. So we will say that the base amount that we want to have it rotated is at, at 90 degrees, right? And then we will subtract from that the amount of how much it will be like normally, right? So right now, if it's at 90 degrees, it's like fully extended, and that's fine. And if it's at 90, it means that this one can then be divided by the other one. And if it's lower than 90, or if it's then it would give us that. Wait. Okay. Yeah, sorry, that took a while. So this will be our parameter of how much of the angle it needs to have. So we're just gonna multiply this, like the amount of that, the amount of 90 degreedness. We multiply it by the results that we get from here, and thus it will give us the amount of how much it would need to be bent here. So now if we put it in here, you see it's more straight when it's like nuts, and if it gets more into this normal shape when it is at present here. Yeah, it's more straight like this, and when it goes here, it gets more like angular. Okay, good. Now that we have that, we actually need to redo this one. I said this earlier, it was a placeholder. And we're going to do this by, first we're going to evaluate a point of where we want to have this thing on, like the things, the springs on. And we want it to be at a strict point, because like at this point this will always be the same. This point will be the one that will be moving, and this one will always be at the same point. So we're going to use point on curve in this case, and we can define the curve, the point that we want to have it, and we still keep, I think, this one for now, like that. And now, however, we have a problem that it doesn't really move like at all. You see, it's kind of like just static, and I wanted to move so those things are more or less at least the same size from the distance at this one. So we can do this in a few ways. I think the one that I think is more like accessible but a little bit like ghetto, let's say, is by dividing this curve and then searching for points that are closer more or less to the original point. So we have the line that we have here, right? And we create a high amount of points, let's say 1,000. And now, or maybe 1,000, I don't know, but we'll see. And now the points will calculate the distance between this point and the other points. And it will give us like a lot of distances, obviously. And we actually need to graph that, so it will be a little bit easier to use. Right? Yeah, I think that should be, or does it? No, I think this one shouldn't be graphed here. Okay. Anyway, now we have all those points here, and we want to say, okay, if this, because this length, not this one here, this length here stays also the same if it's like retracted, and this one here like I wanted to like move back and forth at that place. So we're going to search, for example, we do a larger than search, and we're going to search, and I see like some numbers here, like, you know, like 55, 40, it goes from like 40 to 70 or something. So we're going to use like 60, and this will be like the length of our like not beam, but it's a, you know, a length like steel support, more or less, like little steel support. And it will give us, if it says if it's going to be the correct or false place. And so we're going to use a dispatch, and we're going to dispatch those curves that are illegible or not, and it will give us the geometry that we want to have, like here. So here, for example, it says, okay, only those ones here can be used for this case. And the funny thing is as well is that those will be only the ones that are like eligible for this height here. So if I will increase, for example, the height here, or if I change the general size of those things, you see those things are moving, those points that are defined here are moving up and down as well. And we're going to basically take this like middle thing, and we want to have basically exactly this endpoint over there. So we're going to just list item, and I think it's going to be probably this for the first one, so we're going to just reverse the list, and it will give us the last item here. And this line then will be connected again to our points that we defined here in the beginning, like those ones here. So we're going to delete those. And it might need some calculation or like some trying back and forth, like which is like the correct size. But if I just do it like this, for example, and now I will close the umbrella like we wanted to close it before, like that. Okay, this one will be kind of, this one will leave it. You see when you have it up there, it doesn't really work anymore. But if I increase this amount here, you see it gives us some points, like some lines here. And if I will, let's see how far it can actually go. You see it always stays on there. It's very nice, even when it's overextended. It closes and it goes up like this. So this is our very nice umbrella in this case. That's really good. I like that how that turned out. Great. Now that we have that defined, I want to also define just a very simple mesh on top of it that we are defining here. I'm just gonna use those points that we had here, and we're just gonna do a simple. I think we can actually do a loft, maybe even. Let me check that out. Okay, kind of, but I think if I will. That works, but wait, let me loft options. If I do refit, no, if I do a closed, set boolean true, yes, perfect. It will give us our very nice umbrella here, and this actually turned out better than I expected. That's really great. So just hide this, hide that. Maybe let's actually keep this one on for now because it's our basic structure. And I also want to give it like some pipes to it as well. So this will be something, it's gonna be a little bit smaller one, I guess. Like this. And we're also going to use a pipe on the structure we had here. Might be a little bit bigger. This one, is it? Okay, maybe even this one's a little bit bigger. Anyhow, and we also want to have one for the glorious single one here. That's gonna be a little bit wider as well. So yeah, nice. That works pretty great, and we can obviously open, close it to our needs. Always want to have it, and also if it overextends a little bit, it still kind of works actually. It's very funny. Didn't expect that. And yeah, then we also have our how much do we want to have it curved. If it still works like this, and we can like push it up and down like that. You have a very special umbrella here. So yeah, I think it works pretty great. I hope this kind of like got the idea to Grasshopper close to you. And yeah, I will upload this to my GitHub as well. You can just check it out. And if there are any questions, just please let me know. And yeah, I will see you in the next one.